Hello there and welcome to this course on an introduction to Python programming. My name is Valentine Mwangi and I can't wait to get you started with this particular course. I have been a curriculum engineer for the past 4 years, and what that has entailed is creating learning experiences such as these to ensure that learners who are looking towards transitioning into tech are well equipped in order to build projects, in order to solve for different kinds of problems that they might face in their line of work, or maybe in entrepreneurship if you want. So yeah, so let's get started with our workshop for today. So in terms of how we're going to be going through the workshop, this is just an agenda to just give you an idea at what point we will transition into different aspects of this particular learning experience. So we'll start off with just learning about the learning outcomes. Out of every learning experience, you always need to have some objectives that you're working towards. So we'll get to learn about what these learning outcomes are. Then later we'll go into an overview section where we will get to learn more about those fundamental concepts in relation to the Python programming language that will be important in whatever direction that you want to take when it comes to Python. So for instance, if you want to become a software engineer, if you want to become a data scientist, a data analyst, we'll get to learn about those fundamental concepts generally, what they are, as well as why we need to learn about them. And once we have gotten through that, we'll go through just a reading and a quiz section that will give us some good idea of in-depth aspects of those concepts, so that we are well equipped enough to now go to the next step, which will be now to apply those concepts. So what you're seeing on your screen is actually just a reading that we have curated that will provide you some in-depth aspects of those fundamental concepts. And the idea is that once we have completed going through the what and why section, you go through that theory reading, which is what you're seeing on your screen. It's a lengthy document. It will take you about 10 to 15 minutes to go through. Then once you're done going through that particular document, you will go through a quiz which will just help you to reinforce the concepts that you have understood. So once you have completed that bit about the reading and the quiz, we'll go into a practice session, which will entail going through practice work. We have already also curated a document that contains examples as well as challenges that you can use in order to reinforce the application of those particular concepts, those fundamental concepts that you will need. We've also provided a solution notebook, which is just a document that will contain the solutions to the challenges that you're going to be undertaking, as well as also a project at the very end. So it's important, again, while you are learning some of these concepts, it's important to put into practice those concepts in a real life project, so that you are able to see growth, and at the same time you're able to apply or make use of those skills that you have learned in programming or data science or even software engineering or computer science. If you forget to put into practice, if you don't put into practice the skills that you have learned, then you might again fail to, you might even forget some of those skills. So we have a project that you will be in a position to use in order to put that into practice, as well as some starter code to just help you get started with that project, and also a solution notebook that will contain a solution to that. So generally, when you look at it, this learning experience is quite extensive. So it should take you about 2 to 3 hours for you to successfully go through this learning experience. And if you're stuck, you could always ask questions in the comment section of whatever platform this course has been hosted in, or you could always reach out to me generally if you have those big, those questions that require a whole lot of conversation about, and just reach out to me, Valentine at afterwork.ai, and we'll be able to take this further. I can't wait to help you to acquire these skills and learn more about these skills. So let's get started. So to begin with, when it comes to any learning experience, we tend to work to first of all understand the objectives, and our objectives for today are, by the end of this session, you should be able to use the print function to display the output of a Python program. So a print function is just just for ease of understanding, a tool that we can use in order to display something, in order to show that we have maybe stored some data in some container somewhere. Then we use a print function. We should also be able to use to create and use variables to store data temporarily in a Python program for further manipulation. We should also be able to use comments to provide explanation to how code works. Should be able to use arithmetic operators to perform mathematical operations. We should be able to use data types of different types of data. So these are just classifications that we give to data. We should be able to use those different types of classifications or to assign them to the data that we are working with in order to prepare that data for further manipulation, whether it's manipulation through the use of these arithmetic operators that we're going to be learning. We should also be able to use lists, dictionaries, and sets to store data. We should also be able to use conditional if statements to check for conditions in data, use for loops and while loops to iterate or go through lots of data, as well as use functions in order to write reusable code, or just generally organize our code in a way that is structured. So these are the learning outcomes. At the end of the workshop or this particular course, we'll come back to these learning outcomes to get an understanding whether we will have achieved them at the very end. So starting off, what is Python? You might have heard of already this language. Probably that is the thing that you just Googled, or you just decided to hit the search text box, or you typed in the search text box. And generally, Python is a programming language that we can use for different sorts of applications. And a programming language, just to give you some good idea, is a tool that we can use to create other software. So there are different types of programming languages that we can use, say, for instance, to create software for data science work, for software engineering work, for creating mobile applications, for creating user interfaces. So there are different types of programming languages. But when it comes to programming languages for data science, software engineering, Python is one of those languages that works well for those particular use cases or applications. So Python is a popular programming language that we can use to create or write software or write code to perform data science, data analytics, or software engineering, or even data engineering related tasks. Why would you learn Python? The reason would be that the ecosystem, now the programming language, Python programming language ecosystem, it's well matured enough to a point where if you wanted to do any task related to some of these mentioned applications, there is already written code and tested code by other experts in that area, whether it's software engineers, data scientists, or data engineers, or data analysts. There's already well-tested and production-ready code that you can reuse to do your work with. So, for instance, if you wanted to create a histogram and display something with regards to insights with regards to data, already there is code that has already been written by other data scientists or software engineers that would allow you to create that histogram that you want. So, and that code, we normally refer to it as libraries. So in the case of Python, there's already, we have so many libraries for performing different types of tasks, whether it's data manipulation, creating statistical visualizations or interactive visualizations or dashboards, or performing machine learning tasks. Python has a well-matured ecosystem for that. There are also other various reasons why you might want to consider Python. Maybe the organization that you want to join or a project that you want to do can be achieved or has been proven to have worked can be achieved with the Python programming language. So there's so many reasons. I would leave it up to you, but generally one of the reasons why we would use Python is because of its maturity at this point in time. So the concepts that we're going to be learning in relation to Python are fundamental concepts, and these are comments, variables, arithmetic operators, data types, lists, conditional if statements, dictionaries, for loops, while loops, and functions. These are just fundamental concepts that will be important in any sort of application that you're going to be creating through the use of Python, whether it's the creation of a dashboard through the use of Python. You will get to use some of these concepts, if not multiple of them, if not just one. You get to use multiple of concepts, multiple of these concepts. In some other situations, you might even, maybe if you wanted to build a web application still using Python, you will get to use these concepts. So the idea is that you're going to have understood how to work with these concepts at the very basic level, to a point where you can even create, you can write code using, again, these concepts to perform some sort of operation that you want. So starting off, what comments are? Comments are just simple notes used in our code, the code that we will get to write, in order to provide explanatory notes to other stakeholders. Could be other, if you're working in a data science team, it could be other data scientists. If it's a software engineering team, could be also software engineers. Now, variables, usually we would refer to them, I normally tend to refer to them as just temporary containers. So when you get a data set somewhere, say data set that has been stored in a CSV file, if we wanted to work with that data set, we would load it inside a variable and then be able to apply different operations to that particular variable, whether it's retrieve the column names, whether it's transform the column names in a certain way that we want, maybe to lowercase the column headers of that database. Normally, variables would help us be able to hold that data for further manipulation. Arithmetic operators are just mathematical functions that we can be able to apply to just different values. So these could be addition operator, multiplication, division, subtraction. Could also be some other new types of mathematical operators or arithmetic operators that we're going to learn, which could be an increment operator or decrement operator, which are quite common in programming, and we will get to practice a bit with them. Data types are just generally a classification that we give to just data. So it could be that we wanted to work with textual data, or numerical data, just for ease of understanding, but the numerical data somewhere was stored in a text format. So in order, say for instance, to work with that numerical data, we would need to assign a numerical data type to that particular data that has been stored in a textual format, for us later to be able to apply mathematical operations to that type of data. But again, we'll go deeper into that in the course of this particular course, and we'll get to see how there are different types of data types and how we can be able to assign data types to just pieces of information or data that we have. Lists is just generally it's also another data type that would allow us to store multiple items together. So assuming that we wanted to store, so for the case of variables, we would normally store one piece of data. For instance, if we were to work with age is as a variable. Age could be just that name, age. We could store the value 12 in that particular variable and be able to retrieve that value later onwards in order to maybe to perform some operations. But if we wanted to store multiple values in one variable, we then use what are called lists. So for instance, you might want to store the ages of maybe people within a room or the names of people within a room. Then we can use what are called lists for that particular task. Conditional if statements on the other hand, these are just statements that we can be able to create in order to help us apply some sort of conditions. So for instance, if you wanted to create an application that did some sort of assessment and then later onwards performed a task in relation to the assessment that it did. Say for instance, using that age, if you have 10 people in a room, but you want to maybe give a reward to 2 people who are over 50 people, or over 70, then you could actually use a conditional if statement in your code to be able to assess whether the ages of each and every person is greater than or less than 70. So conditional if statements usually come in handy when we want to perform some sort of assessment in code. Dictionaries are another way of storing data, more like variables, but in a variable you only store one piece of information. In a list you store multiple pieces of information, but in dictionaries, yes, you can store multiple pieces of information, but you can introduce one dimension, and dimension would be so for instance, for each and every age that we have, we also want to store, we have in a list. So initially we stored one value in the variable age. That was, let's say, 12. That's the value of that's the age that we would store in the variable age. So if we wanted to use a list, then we would say, let's say we wanted to store 2 items or 3 items. It would be 12, 15, 20. So if we wanted to use a dictionary, instead of not only just storing 12, 15, 20, we might decide to also store some extra information in relation to that 12, 15, or 20. We could store the name of the respective person who has that particular age. So in a dictionary, we would have first name, say for instance, or name as the other dimension that we would want. And normally data in such a format would be referred to as data that is stored in a key and value format, where you have some sort of key as well as value that that are paired, and they are actually paired and stored within a dictionary. For loops allow us to be able to iterate over some sort of sequence. So if we had some data set again that we had stored maybe in even just a variable, we can, or even just a list. Let's just use a list for just ease of understanding. Assuming that we had this list which had again 2 values, 12 and 15, then we wanted to apply some sort of operation to both items, then we can use a for loop to go through that list. The first time the for loop goes through the list, it would go through the first item, that's 12. Then the second time it would go through 15. And for loops usually come in handy, assuming that you had maybe 100 records or 20 or 100 or thousands, I don't know, so many. So you can use just a for loop to be able to iterate over all those records and apply some sort of operation that you want. So instead of writing as much code as you have the elements or the items within your list, you can just use a for loop with this, which is usually 2 lines. You can, 2 or 3 lines, or just 2 lines to be able to perform some operation to just the entire sequence. And a sequence could be a list, a dictionary, could even be just a normal string, which a string is just a collection of characters. While loops are more like for loops, only that you now introduce some sort of condition, like having some conditional if statement. So while loops usually incorporate some sort of condition or assessment when you are iterating. So we also get to learn about that. And lastly, we're going to learn about functions, which would help us be able to organize our code in a reusable generally way. So for instance, if we had written maybe 100 lines of code and we wanted to perform a task that did the same as the first 10 lines of our code, we could always decide to go back to the original code that we had, then create then group that first 10 lines of code into what is called a function. And whenever we want to perform a task similar to what the first 10 lines of code do, we would just simply call that particular group of functions again and again, rather than rewrite our code every time that we want to perform the same task. We are just going to be just calling that group or collection of that group of code to be able to use and be able to perform the task that we want. Now, these are just some fundamental concepts. They're usually the first to go concepts in relation to Python. There are some more advanced concepts that we won't cover in this particular workshop or this particular course. However, we will provide some more material. If you want, you could always just go a bit more deeper to get to understand what those particular concepts are. So at this particular point in time, the next thing that we're going to be doing is to go through now the reading and the quiz that will be in relation to what I've talked about. And this reading had earlier shown you is this actual reading, which is on your screen. And it should cover now what we have talked about in depth and give you a sense of what each and every concept that we've talked about entails. Now, once you go through this particular reading, the idea is that you will get now later to work on this quiz, which again, we have also shared depending on the platform that you're using, and you can be able to the quiz is actually self-graded. So the idea is that you will have really enhanced your understanding of these concepts and be able to now undertake the next step, which you will be now just going through the practice work for this particular session. If you're coming in from YouTube, unfortunately, you need to become an Afterwork member in order to have access to the reading and the quiz, but we'll provide a sample solution notebook that you can be able to use for the practice work. So at this particular point in time, just follow the link to the resources that we have shared and have a look at the reading. Go through that reading for about 10 minutes or 15 minutes, then go through the quiz. And if you feel if you're confident enough to go through the quiz by yourself, then without even going through the readings, then it's okay. You can always do that. So you can pause the video, then we'll come back after 10 to 15 minutes. But I'll continue after this. All right, so the next thing, once we have gone through the reading, the next thing that we're going to be going through is now these concepts that we have talked about theoretically in a practical way. So we are going to go through each and every concept. And then once we have gone through that, the idea is that you're going to be working on the challenges. I'll help you to go through the variables, actually all the concepts, examples, and I'll be pausing. I'll be giving you time. So once we have finished, say, the examples for one particular concept, then you can work on those challenges and also verify your answers with the solution notebook that we will have also provided for this particular course. Again, if you're coming in from YouTube, you only have access to the examples, but again, you can always become a member to be able to get access to the challenges, solutions, as well as the project later onwards towards the end of the course. But feel free to just follow through if that's your interest. All right, so starting off, once you have followed the practice notebook link, it should take you to this particular page. So what you're seeing here is a notebook, and a notebook generally is a document that data scientists or data analysts would use in order to save their work and be able to share it with others. Now, a notebook, you can think of it as more like a Word document, only that inside a notebook, the distinct feature is that you're able to run code. And so, that's what we have created. We've created a notebook that contains examples as well as challenges for the course that we are meant to be taking, which is Introduction to Python Programming. So once you get to this particular page, the first thing that you need to do is to go to File, then you go to Save a Copy in Drive, and what will, File, then Save a Copy in Drive. So what that will do, it will open a new tab with the exact same notebook. And the reason why we would do that is because this is an original notebook. The one that you're seeing on your screen is an original notebook. And if you save any changes once you have done the challenges, you won't be able to save them anywhere. Or if you close down this particular window, it won't take into account of the changes that you will have made, especially with regards to the challenges that you have. So by going to File, then Save a Copy in Drive, it will open a new tab that will contain a copy of this notebook that you can be able to now save in your Google Drive account. So once you have done that, so just go to File, then Save a Copy in Drive, and be able to do that. I'll open mine in playground mode because I don't want to make any sort of changes to this particular notebook. Just to give you also a good introduction, because this is your entry to working with notebooks. Notebooks are, again, as mentioned, documents that would allow you to have executable code, but at the same time, you could also put in any different content that you want, or link any sort of content that you want to this notebook and be able to share it with others. The original project with regards to notebook is called Jupyter Notebooks. It's something that you can look at separately. And it's an open source project that allows you to also be able to work with notebooks locally in your machines. You can be able to do that. There's a platform called Anaconda that allows you to install that original project, Jupyter Notebooks, in your machine and be able to run them there. However, what we are using is another platform that allows us to work with Jupyter Notebooks on the web, so you don't necessarily need to install Python. So the idea in your computer, so the idea is that we're going to be running our code on the cloud, and the servers that are going to be we're going to be using will be provided by Google. And these documents, the ones that we're going to be using, are much more similar to any other Google workspace documents or Google Drive documents that you might have, such as Google Sheets documents or Google slides documents. Only that these ones are notebooks, but they're supported by an application on Google Drive called Google Collaboratory, or Google Colab in short. So again, I just wanted to get that out of the way so that you have a good understanding of what exactly we're working with here. Now, once we have created a copy in Drive, so the next thing that we need to do is to now connect our notebook to Google servers, which you can do by clicking the connect link at the very top right. It's like a button, but to just connect to Google servers. That will allow us to be able to work with now, to be able to execute our code. It will take a bit of some time depending on your internet speed, but once it does that, you'll see a check and it will say connected, as you can see here. And now we're good to go. Now, in a notebook, we normally have a code cell as well as a text cell. A text cell can contain just tons of text information, as well as links to interactive media, etc., maybe videos or even just images. You can also put in images. The language that we normally use, so in notebooks, we also normally have what are called you can write notebooks in a language that's called Markdown, but it's usually quite similar to just text, just the normal text that you write, only that for possibly something like a heading like this one, which is a bigger heading, you would usually use a hash or a pound character in front to be able to say that this is actually a heading. But if you maybe want to have another smaller heading, you can use a double hash, this H2, H3, heading 3, heading 4, which are much more smaller than the other ones. But generally, over time, when you get to use notebooks, that should be a bit more straightforward. So once we have done that, we've connected and I've understood that we have a text cell, a code cell, and a code cell, but I hadn't explained a code cell. By the way, a code cell is generally is another type of cell. So in a notebook, we have different cells. You have text cells and code cells. In code cells, you can be able to put your code and be able to run it. And in text cells, you can be able to just put just content, text content. And what you're seeing here is just a text cell. And inside the text cell, you can contain other text cells. Like for instance, here we have, this is a text cell, but it contains other text cells as well as code cells. So we'll go through first of all the first bit. So to expand it, you just click on this arrow. It will expand, or you can even just click in the middle over here. But don't click on this icon. It will run every other code cell inside. So let's expand this, and we'll first of all go through the variables concept. So starting off, what is a variable? I had mentioned earlier, and we have already gone through that in our reading. A variable is a reserved memory location that we can use to temporarily store data before manipulation. So we can put some value in a variable and then later onwards perform some operation to that particular variable. So let's expand that. Example 1, let's go through these examples. Now, we now have expanded all the text cells and we've gotten to this code cell. This code cell has this content. There's this content. But whatever that you're going to be seeing in front of a hash is just an explanation of what happens to the content that comes next that doesn't have any hash character before. So what we have here is just comments, and what we have here is just now our code. So in order to run this code, here we have a variable, by the way, just to explain. A variable is a container. So A is just the variable. And a variable, you can give it any name. It could be house, it could be letter Z, it could be letter or Z, it could be a table. A table is equals to maybe mahogany, or it could be, a variable is just a container that you can give a name. But again, there are rules to writing variables. For instance, you must begin with a letter, an underscore, or a non-number character. So let's continue. A minute. All right, so just to continue, just a minute. So to run this, we need to click on this particular icon over here. So we click on that to be able to run. If you haven't created a copy, you might see this warning, but let's run it anyway. All right, so that should be good to go. So once you have done that, what has happened is that our code has been run. A is equals to 10. So we stored this value 10 inside the variable A. And we use what is called an assignment operator, which is an equal sign, to be able to perform that operation. So if you run that, we have stored 10, the value 10, inside the variable A. Let's go to example 2. Again, what we did in example 1, we stored an integer, which is some numerical data inside the variable A. So we can also do that with textual data. So we can store, say, this particular piece of text, Earth, inside planet. But in order to be able to store pieces of text in a variable, we need to put those pieces of text, that piece of text, in quotes. So it doesn't necessarily need to be just one word. You can have multiple words, etc. And just generally, that's how it would work. So you cannot be able to store Earth like this. This is going to bring an error. So what we need to do is put some quotes like that. And let's run this. All right, that's good. Moving on, example 3. Now, if we wanted again to create what is called a list will contain multiple items. Here we had an integer, or just one numeral piece of data. This here we had some text data, and here we have multiple pieces of information. If we wanted to store them in one particular variable, then we can just create what is called a list. A list is what is shown here. We have a square bracket, a left bracket, and a right bracket, square bracket. And inside we separate the pieces of text that we want to store together, and then we enclose them in square brackets. But again, we separate those pieces of text with a comma. And and we store them as shown, so using the assignment operator. But we also get to learn more about using other types of, even dictionaries. We can also do the same thing, but we would store data in a variable in this manner. All right, so at this particular point, the next thing that you need to do is to go through the challenges. There are 2 challenges. Go through them, and once you have done that, just go through the solution notebook, which will give you an idea of what would have been a sample solution to that particular challenge. You can pause the video, and then we'll continue to the next section after. All right, so once you have gone through that particular section, the next bit that you're going to go through is printing. So the print function is what we normally use in order to print out something. So if we wanted to print maybe some message on the screen, then we can be able to use the print function. So for instance, in our situation, if we wanted to print out what is stored in the variable for or planet or a, then we can use the print function. But to start us off, just to understand what the print function does, behind the scenes, there is some code that allows us to print something on the screen. So you could write the code to print out something, but already that code has been written, and you can be able to access it using this particular print name, as well as the 2 parentheses that you see here. Now, we can print out any sort of text. For now, we won't print out variables. We'll print out just some different text. Let's say, for example, wanted to print out the text hello with an exclamation mark. This is how we can be able to do that. Print hello, then, as shown. If I run this, I should be able to print out hello on my console section, which is at the bottom of this particular code cell. All right. The same case, example 2, if we wanted to print out possibly 2 different pieces of information, but separate them with something, say print Valentine, and we can be able to do as shown. So we can specify first inside the parentheses of the print function, specify the first piece of text or piece of data, then put a comma to separate now that particular piece of text with the next piece of text that we want to print out together, which is this. Then we define the separator. The separator will actually be what will be separating those 2 pieces of text. So in our case, we have specified that we just want a space. So if I run this, by the way, you can use Shift Enter as a shortcut to just clicking on this particular icon. So just Shift Enter. So hello Valentine. So there's a space in between. If you change this to a separate, maybe a hyphen, you will see a hyphen showing up in between. All right, example 3. If we wanted to print out some sort of if we didn't, so we can be able to print out something in a different way as well, not necessarily using a print function. But we can also just use if we stored a variable inside a variable, so if we stored some value inside a variable, then we can just call the variable or in order to print out what's installed. So for instance, just going back a bit, if I wanted to display what's stored in 4, I can just say, just move on to the next line, 4, and I run this, and I should be able to see 4 appear in my console. So the same case over here. Example 3 here. This is actually a set, not a dictionary. So if I wanted to print out, if I wanted to display what's stored in colors, this is how I'd be able to create. What is the curly braces? This is not square bracket. If it's square bracket, again, it's a list. If it's curly brace, but it does not have a key and value, then it's usually a set. When you have a key and value, which we'll get to see, which sometimes could be something like color, something like this, color red, etc. In such a situation, but now we need to put something like this. So color red, this is a dictionary, but we'll come to learn more about it. The idea here is just that you know that we can be able to print out what's stored in a variable just by simply not using the print function. But most of the times we use the print function because the print function can allow you to print out whatever you want, even in between pieces of code, as opposed to this particular method. But it's just good. It's important to just know that you can be able to do that. All right, at this particular point in time, you can work on the 2 challenges and then verify them from the solution notebook. Then we can continue. All right, comments. So far what we have been doing is running code, but at the same time, without me explaining, you can be able to know what's happening in the code that we have by just simply reading the comments that accompany the code. For instance, this particular section, which has pound characters or hash characters in front, is a code section. The same case here. This is just comments. The same case here. These are just comments, and comments are just explanatory code that allow us to be able to write pieces of information that will help us learn more about the code. So going through comments, how do we write comments? So we can be able to write comments as shown. So we have a hash character in front, then we write our piece of text that will be just explanatory code, and this is how we can write it. Or alternatively, you can still write the hash in the same line as our code, but whatever that comes after on the right hand side would actually be treated as a comment. So if I run this, what will be run won't be the comment, but it will be the code that is within that particular code cell. Something else to note is that, just to provide some good explanation at this particular point, it's important to understand that when it comes to writing code generally, especially Python, the code that we write, say Python, normally would be run by some other program, special program that runs programming code. And in the case of Python, that program is called an interpreter. So when we say that we're executing code, it's actually an interpreter that runs that code. And in our situation over here, the Python interpreter does not run the comments. It only runs the code that we have. And it's usually the same case across different programs, programming languages, where you have some sort of you have some sort of program. There's an interpreter for that language, or in some other cases, they're what are called compilers, which is just programs, special programs that run the programming code that we have. So just wanted to highlight that, but this is how we write single line comments. If we wanted to write multiple line comments, we could have multiple hashes, like as we did here. Here we have multiple hashes, and what is here, it's actually multiple line multi-line comments, multiple line comments. But again, we can also use what is called a delimiter character. It's just single quotes, but 3 single quotes. We would need to write 2 sets of 3 single quotes and then enclose our content or text that will be treated as a comment inside those 2 sets of delimiter characters, as you can see here. So you can run that, and this will be treated by the Python interpreter as just generally comments. So what will be run is this. Example 3 also just covers how we can be able to use the pound or hash characters to just write code, to write comments. So we can also run that. All right, so work on the challenges and then we can continue. All right, moving on. The next thing that we are going to be continuing, we're going to learn now are arithmetic operators. And these are just mathematical functions that we can use to perform some sort of operations with. So for instance, if you wanted to take 2 values or 2 variables, add 2 variables together, and then we can use arithmetic operators. There are different arithmetic operators. That there are quite a number of them, but we're going to just learn about the basic ones. So there's just for a start, addition operator. So we'll start off with this particular operator. So first of all, we can be able to declare our variables. So by the way, creating variables by assigning values to variables, we normally say that that action is usually referred to as a declaration. So we declare variables. So for instance, we declare the variable A and variable B in this particular situation. So and they have these particular values, and addition. So once we have done this, once we have declared our variables, we can be able to perform some addition operations. So say A plus B, and then store the value of A plus B in C, as you see here. So A plus B, the positive sign operator is the is the mathematical function that we are referring to. And so we store A plus B, the outcome of that in C, and then we print out the results of C, and it should be 50. The division operation, the same case. This is how we write a division operation with a /. So A divided by B. So again, something else, when we write code in our code cells, the values of the variables that were initially stored in a previous code cell would still be accessible. So we can be able to access the variables, the values, or even those variables from this new cell. So A plus B, so A divided by B, as you can see here, the outcome of this would be stored in D. So A, that's 40 divided by B, that's 4. So the outcome would be 4. But when we do division, we would normally get a decimal point, or what is called a float, as an outcome. So we would get 4.0. Declaring again, now we can now use what are now programming specific operators. We've gone through just addition and division, but now we can work with what are called increment operators as well as decrement operators. And what these two operators allow us to do, so for instance, to work with an increment operator, we can be able to simplify the expression that we had. So for instance, A plus B, A is equals to A plus B. This particular operation, we can be able to simplify it using an increment operator and rewriting it as you see here. So A plus or equals to B, which would just generally refer to this particular expression. So what would be stored here? So A, the outcome of this would be, which is A, would be A plus B, which would be 40 plus 10, which is 50. So the outcome would be 50. So ideally, we are rewriting this expression, but now using this expression. It's like when we run this particular piece of code in this code cell, we're just running this particular piece of code. So A is equals to 40 plus 10, which is 50. Yeah, so but let me just do that. We'll get 50. And we are redeclaring our variables. No, not redeclaring. We are declaring them again. So we don't want to use the original A's and B's. We just want new ones, new values. So we'll get 50. So this is the increment operator. We can also use the decrement operator by putting a minus sign in front. So a subtraction sign in front. So it's going to be more like this. So the short form of this is just generally something like this. So if you run that, you should get 30. All right. Now, there are two other operators that we're going to learn. There's the exponentiation operator as well as the modulus operator. Now, if we wanted to get a remainder of a particular sort of expression or some sort of mathematical operation that we're doing, we wanted to just get a remainder, which is usually useful in programming use cases. For instance, if you wanted to iterate over certain records, say every other record, and in order to implement that iteration, and we would, first of all determine whether this record is even or odd. If it's odd, there's usually a remainder 1 whenever it comes to some operation that we're doing. But that's a bit more out of this. But the idea is for now is just to understand that we can also work with an exponentiation operator, which as shown is more like this. So 5 modulus 2, so not exponentiation. This is a modulus operator. So 5 modulus 2 is equals to 1. So it's 5 divided by 2 is 2 remainder 1. So, but in our situation, the modulus operator returns the remainder. So 5 modulus 2, the remainder is 1, which is what we have here. So 5 modulus 7, 15 divided by 7 is 2, remainder 1, because 7 times 2 is 14, and remainder 1 for 15. So the outcome over here, if we run this, we should be able to get 1 is the answer. I'll run this. Please note that this is also commented out, which means the interpreter won't run this line of code. This is usually one of those practices when we want to isolate part of our code. We can just comment it out, as you can see. So we get the outcome as 1, which is the outcome of this particular operation. So that is just a bit. Now that's the modulus operator. Now we can use the exponentiation operator. If you wanted to raise something to the power of something, then we can use an exponentiation operator, as you can see here. So 5, which is usually 2 stars. Maybe if you wanted to raise 5 raised to power 2, which is usually 25. This is how we can be able to apply that operation. We normally don't have, raising if you want to raise something, you can be able to do it like that. In calculators, they usually use this particular sign, but in programming, we don't usually use that. Especially with regards to Python, we usually use double stars to be able to do that. Let me remove this comment. You have to remove even the space before the print in order to have this working. Python is usually sensitive to space. In our situation, we'll get 1, which will print out this, and also we'll get 25, which will be the outcome of that. And that's it. Work on the challenges, and then we'll continue to data types. So the next thing that we're going to be going through is the data type section. So a data type generally is a classification that we can be able to assign to some sort of data. And that could be integers, and it could be string sort of data. It could be just float data. So data usually comes in different format, and data types just allow us to be able to perform such sort of operation on those particular pieces of data, and also just the respective operation in relation to that particular data type. So for example, if we are going to be working with maybe age type of data, then it would come in handy. The data type integer would come in handy because normally age would be suitable for that, because integers are just whole numbers. But again, you can't have whole numbers less than you can have age less than -1. So that is also something to take into account. But yeah, so we're going to be assigning data types to data, and then be able to perform some sort of operations later. So we have these distinct 3 data types, is integer, string, as well as float, to be able to work with. When it comes with to Python, this is the type of, these are just the common data types, but there are other data types that will come in handy after in your learning journey. So we'll start off with the first type of data type, integer. Integer looks like this, just whole numbers. So in our situation over here, if we wanted to determine the data type for X, we can be able to use the type function, and then we pass our X or the data that we want to check the data type for. In our situation, it's the value 50, which is an integer. And then we'll print out the data type itself, which in our situation over here will be integer. But Python will print it differently, but you'll see how it will do that. We do the same sort of operation, only that in this situation we have X as a string. We'll also be able to see that as an output. And normally that type of data, or textual data, which is usually a string, we would normally enclose it in either single or double quotes. Doesn't really matter. Float data types are usually just more like decimal point numbers. So in our situation, 90.0 would be a floating point number. It would actually have a float data type because it's a decimal point number. Normally, data that would be suitable in this situation would be maybe like currency data, etc. So let me run this. Should be able to get 3 different outputs. So this is what I mentioned, like, Python prints it out this way if you want to look for, if you want to determine the data type. So for instance, the first print operation here, 50 was an integer, then we have 30 as a string, then 90 as a float, 90.0 as a float. Example 2. So once we have done that, we can also, now we have learned how to determine the data types of just whatever data that's stored in a variable, we can then later actually perform operations to do what is called type conversion. If we want to have a piece of data to have some data type that we want, then we can be able to do that as shown. So 40 plus, say, y. If we wanted to perform this operation as it is, say x plus y, without considering the data types, we would get an error because we have an integer and also we have a string, so we would get an error with that regard. So instead, what we can do is to perform what's called type conversion, data type conversion. So we convert this string into an integer. So we would get 4 as an output if we convert it into an integer. So we can see here int, we use the int function and we pass y inside, like passing it. We give this function an input, which is y, and that will give us, the output is usually a 4, just the number 4, and 4 would be used in the operation. So x, which is 40 plus 4, which is 44. Something to note is that this only works with only numerical data that has been enclosed in quotes. There needs not to be comma inside that. So if you have maybe 1,000, you need also to remove the comma. And in such a situation, if you, in situations where you have now say for example data, numerical data written in words, then you would need to use other what are called other methods, other advanced methods to be able to convert that particular piece of information into textual data that you can use for such an operation. So if you add this, we should get 44. But if you remove int from here, so if you do this operation, you will get an error. So if you do this operation, you will get an error, and that's the second way is how you resolve it. So this error just tells us unsupported operand type for, this is an operand, like that operator type for integers and strings. You're not able to perform this operation where you have an integer and a string. So I'll just redo that and do that by just going Ctrl-Z, Ctrl-Z. Example 3. So if you wanted to, again, automatically, this is a different example. So here, let's even just understand what's happening here first. So we are storing 20 inside x. So we are assigning 20 to x. Then we are determining the data type for that, which is an integer. Then we are printing that. And then later we are performing this operation, which is x is equals to x plus 5.0. So a shortcut for this is just comment out x is equals to x plus 5.0 for if you don't really understand what's happening. So x is equals to x plus 5.0. So what we're going to be doing is taking 20 plus 5.0, which is 25.0, and storing the outcome, which is 25.0, into x, and printing out 25.0 with this line. And then here we're determining the data type for x, which is again 25.0, which is a float. So we have an integer. Then here we have a float. Here we have 25.0, and we have a float. So if I print out this, so integer 25.0 and float, the idea here is that you're able to understand that in any situation where we are adding an integer and a float, the answer is always a float. So maybe you could pause and try to understand any operation x plus 5.0, the answer is always a float. dividing integers to a float. So we can do the same. Well, you can also divide anything that you divide to actually be a float. So 40 divided by 5, well, the result will always be a float. Or 5 divided by 40 will always be a float. By a float, or whether it's even just exact, it's like 40 divided by 5, it's usually 8, but as had highlighted earlier, that would result to 8.0. So and this other one would be 0.125, the answer. So 0.125, yes. Okay. So I hope you understood what's happening here. So the output of a division operation is always a float. Again, like we did here for integers. So here we we converted this text into an integer. We can also do the same case for a float. Instead of an integer, we do a float. So b here was a 5. Divide by float 5.0. So 5 divided by 5.0. We said every time you have a division, the answer would be a division. So 5 divided by 5 is 1.0. Another operation that we can do is to concatenate or to add two strings together. So we can combine two strings. In programming, we generally in Python, we say it's concatenation. So we can join these two strings, but we use the addition operator. This what simply does, it just combines these two strings or pieces of text. But the only thing here is that there's a space here. So John Doe. So if I run this, I should be able to see John and space Doe. Example. All right. I think that's it. You can work on the challenges. Pause the video. Once you're done, check the solutions, and then you can continue. All right. The next thing that we're going to be learning is about lists, and these are a list is just a way of storing multiple items, or by definition, it's a compound data type that allows us to store multiple pieces of information which could have different data types, and that collection of different types of information would be related somehow. So for instance, in our situation over here, we have a list that's called fish, and it has these elements. There's salmon, there's starfish, there's tilapia, and there's swordfish. Now we have inside this list, we have what are called elements or items. We have 4 different elements. So in our situation over here, if we print out our result, which we can print out not necessarily using the print keyword, we'll be able to see this list actually, salmon, starfish, tilapia, and swordfish list, which you can see here separated by commas. We can also perform different operations. We can add an element to this list, or an item to this list. Element items, just the same thing. We can remove or we can update the existing ones, etc. So adding elements to a list, so we usually use the append function. So append method, append function, you can call it just a method or function. So in our situation over here, we just call it a method. A method and a function, they're usually just the same thing, only that methods are stored somewhere, usually classes, but let's just use just function for ease of understanding. So our function over here, it's called an append function. Inside the append function, we write the element that we want to append to this list. So we say fish dot then the append function, then inside the append parenthesis, we define that. And the outcome of that will be a list that will have salmon, starfish, tilapia, swordfish, and goldfish, which we have. If you run this a second time, you will have another goldfish added. So because already you have made changes to the fish list, so if you do that, you'll also get another list added. All right, updating an element in a list. So we might want maybe to update maybe one particular element. That is tilapia. We might want to update it to Nile tilapia. So what we need to do first of all is to define the position of that element in that list. So elements in a list usually have positions. So the positions usually start from position 0. So in a list, you have this is position 0, the first element. The second element is position 1, 2, 3, 4. So in Python, lists usually have elements which have positions, and positions start from 0, 1, 2, 3, 4. So it's important, first of all, to define the element, the position of the element or item that you want to update. So in our situation, we have Nile tilapia, which we want to update on the second or on the item that has a position 2. So this is position 0, position 1, position 2. So this is position 2. So this is how we define position 2. So fish, the element in position 2, Nile tilapia, use a square bracket. So if we run this, we should be able to see now a new list with Nile tilapia. Right. If we wanted to remove an element from a list, so if we wanted to remove goldfish, we can use the remove function and define just any goldfish. So any instance of this particular item will be removed. So if I run this, I should be able to remove that. So if you had multiple goldfish, they would also be removed. All right. Now, how can we retrieve elements from a list? By the way, lists are usually useful, especially when you want to, for example, maybe perform some sort of operation on certain related items. Maybe you had some column names from a data set and you wanted to maybe do some sort of operation. That's where you would, work with lists, or even you could use other different types of storage data structures like dictionaries, which we'll get to learn about in a few. So in our situation over here, we get the first item in the list. So first of all, we can be able to define, in order to get an element from a list, we would say reference the list itself, fish, then square brackets, then we define the the position of the element that we want to get it. So in our situation, first element is position 0. That's what will be printed out. If we want to get the first two elements, we would introduce, so we would define the first two as shown. So we say we start from position 1, then we put, this is where on the left-hand side of the double colon is where we want to start our fetch or our selection from. Then on the right side of the double colon, we would define the item that comes after where we want to stop. So the first two elements, so position 1, the first element is at position 0, the second element is at position 1. Then we want to stop there. So we define the next position as where we want to stop from. So we don't want that. So that's how, I'm not sure why they did not think of implementing it as 0, then to position 1. But in programming in Python, we usually do it this way. So 0 to position 2. And this will just give us the first two elements. If we want to get the last element, we now, instead of defining the first element, we usually use a minus. So minus will start from the other side, -1. So this will give us the last element, double colon, then don't define anything there. We'll be able to get the first element. By the way, some of these things, you just have to play around with them for you to have understood how they go. They, have understood what happens in whatever situation. So getting the 8 elements from the second position to the end of the list, this is how you can be able to do. So if I run this, I should be able to see our output for each. So first element, salmon. First two elements, salmon, starfish. Last one element, which is swordfish. And getting items from second position to the very end. So Nile tilapia, swordfish. So this is second position to the last item, swordfish. Just play around with different numbers. Try to play around with those particular positions, and you should have a firm grasp of them. And then you can just work on the challenges as the next thing to just have a good idea or good grasp of those concepts. Right, moving on to conditional if statements. Conditional if statements, we normally use them for decision making, and we can be able to create an assessment whether if this particular statement evaluates to true, then we can perform some sort of operation, or if it evaluates to false, then we can also perform some other sort of operation. So for maybe if we wanted to check whether two variables are, we wanted to perform some assessment or some expression on some two different variables, then we can do that as shown. So we use the if keyword to create what is called a condition. So if maybe if Q is less than P, if Q is less than P, which is true because 100 is less than 5, then we want to perform this operation. This just marks, this double colon just marks the end of our first of our expression. This is an expression. This is the if keyword, and whatever that comes in the indented section. So you need the next line, you need to indent it. Is usually whatever comes in that section is usually part of the body for this particular if statement. So what if this particular statement expression, this is an expression, Q is less than P, evaluates as true, then we're going to run this. If it's not true, we won't be able to run anything. It will just continue. So if I run this, Q is less than P, which is 400. So Q is less than P will be printed out in the console. You can also change that to greater, and you will see that we won't have anything there, because we haven't specified what, because this has turned out to be false. If it had turned out to be true, then this would have been run. All right, we can also have if statements inside if statements. So for instance, in our situation over here, we have an if statement, this if statement inside this if statement. Not only that, we can also apply multiple if statements together. So this is one, but we can also have if Q is less than P, it was Q is less than P. We could also have another one that says L if Q is greater than P, then we have print Q is greater than P. So in our situation, but Q is but if I add 0, so that this one evaluates to be true, so Q greater than P, we should get Q is greater than P. So we can use what is called an elif to include another expression. But again, you could still have all these ones turn out to be false. That's when we now say whatever anything else that happened, we can just say else, else, print, something. P is equal to Q. And this expression, all these will turn out to be false only if, say for instance, Q is also 500. So we need double colon, sorry for that, double colon. P is equal to Q. If you get an error, sometimes you can read about the error. Sometimes you can just refer to a concept that uses the same. So you can just use a double colon, which says syntax error expected. Run that, and you should be able to see that. So let's just run that. P is equals to Q. So, but the idea, I just went a bit fast a bit there. But the idea was assuming that you had, for instance, multiple expressions that you wanted to perform on. Say, for instance, S is less than R. If S is less than R, then we perform this other expression for Q is less than P. And if it is, then we say Y is less than X. And if S is is equal to S, R is equals to S, and then we can say print is equals R and S are equal. So you can just play around with these different keywords. The different keywords, there's the if keyword, there's the elif, and there's also the else keyword. But just note that once you have written an expression and you're done, just put a double colon at the end. For instance, in our situation over here, we have, I think what I had described a bit earlier here, the else keyword, which you can be able to use as shown. So generally just play around with these ones and be able to work around them. And you can use the these operators. So this is equal, double sign is equals to double equal sign. It's actually equivalent to the equal sign. So there's less than, there's greater than, less than, greater than, there is also equal. We're also going to learn more about what are called and which we are and or keywords as well, but just work with those ones first. So there's an and keyword. So for and, what an and keyword would do is, instead of writing, for instance, our situation, two multiple if statements as shown, you could decide to write these statements in one line. So you can say if S is less than R and Q is less than P, then Y is less than X. So instead of nesting the if statements, we can write them in one line. So for instance, we have two variables, Mary, name and age. So if name is equals to Mary and we use the and keyword, age is equals to 30, then we print out this. So if I run this, I should be able to get what that particular bit, what is in the if statement body, the body of the statement. All right, example 5, if wanted to use the or keyword. So here we have A is greater than B. So if A is greater than B, or A is less than C. So or would only, actually, or would be that we would evaluate the body of the if statement if any of these two statements separated by the or keyword turn out to be true. For and, both of them have to be true. Name is equals to Mary and age is equals to 30. But for or, A has to be less than B, A has to be greater than B, or A has to be greater than C. So any of these conditions, if this turns out to be false, then we check this other one. If it turns out to be true, then we run this. But in our situation, if this turns out to be false, then you move on to the next. We won't print anything. This won't be printed out if any of these are false. But if any of these are false, you can still print out what is in the body as long as the other one turns out to be true. All right, work on the challenges and then we'll continue from there. All right, moving on to dictionaries. So we've already talked about how we can be able to work with variables, how we can be able to work with lists, but dictionaries usually introduce some sort of dimension to when you're working with just temporarily storing data. So for instance, if we wanted to create a dictionary and store some data related to vehicles, say for instance, we have this dictionary called vehicle, and inside that dictionary, we would normally enclose them in curly braces. We would have brand, it's Toyota, model is Subaru, and year ends 2019. So brand is a key, model is a key, year is a key. Toyota, Subaru, and 2019 are values. So what we have inside this dictionary is our key values. And this is how you can be able to print out a dictionary by just simply going to its referencing its vehicle, its name. So that's how you can be able to print out and also create a dictionary. Again, like lists, we can be able to add items, add key value pairs into a dictionary, retrieve them, delete them, etc. So assuming that we wanted to add a new key value pair to this particular dictionary, so engine is the key as well as the value is 1800cc, we can be able to do that as shown. So we specify the dictionary name, then the key value, the key that we want, and then the value that we want. So if we run this, I should be able to see now an extra key value. Initially, we did not have that as part of that. All right, continuing. Update an element in the vehicle dictionary, so we can be able to do that as shown. So assuming that here we had engine is 1800 and wanted to update that value, so we would say vehicle, as you can see, vehicle engine, we specify the key, and then the value as the new value is 2400. So if I run that, I should be able to get that as the outcome. So vehicle, the engine has a value of 2400 cc. If wanted to access an element, so wanted to access the value for this particular key, so Subaru, that's what we wanted, we can do it using these two methods. We can specify the key and using the first method, using the square bracket method, or the get method, as you can see here. And then we can also remove an element from a dictionary. So we're going to remove, and which we can be able to remove key value. So model. So if we wanted to remove entirely model key value from wanted to remove an element with a key model and a value which will of course be Subaru, we can do that as that, but we haven't specified. It will just remove all the model keys. So in our situation over here, we can say vehicle.pop to remove, and this will be the outcome of that. But it's a strange method, but this is how we normally would do it. Lastly, if we wanted to check whether an element exists in a dictionary, we can use an if statement. So if you say if now the element or the string that we want to check, or it will check the key value, the key that we want. If brand key exists in vehicle, say yes, key word exists in the vehicle in the dictionary, and no, it doesn't. So brand does it? Yes, it does. So we should be able to see that. But if I say model, I wouldn't be able to find that there. All right, so work on the challenges and then verify those challenges with the solution. The next thing that we're going to go through is the for loop. For loops generally would help us iterate through or go through each and every item within a particular sequence. So for instance, if we had maybe some sort of string, which is just a piece of text which comprises of just different characters, then we can be able to use a for loop for that. So for instance, in our situation here, we have the string Karuna. If we wanted to go through each and every one of them, maybe go through the for loop and capitalize each and every letter, then we can do the same thing. But here we just want to print out the value of each and every letter in this particular string. So in our situation, here we declared our variable a, then we use the for keyword, and y is just that variable that we want inside a for loop that will contain the value of the current item. So y in a, then print out y. Y is now the current item. So the for loop in a is just, you know, a is just the sequence that we are working with. It could be a list, a dictionary, etc. So in our situation, we are going to go through each and every. So the first iteration, we print out capital K, then A, then R, then U, then NA, etc. Space even as well. So if I run this, I should be able to see the output of my iteration. Now, in the case of a list, so assuming this is our list, which just contains list of restaurants, if we wanted to loop, it's almost a similar case, like for X, now X will contain our current item during each iteration. So we would, inside that for loop, would however have multiple lines, not just one line that we had initially here. But here we are going to, inside the body of the for loop, first of all, print out the element, the current element in that sequence. And then we are going to check, have an if statement. So it's going to check whether the value of that item or element is viridian. If it is viridian, then we are going to break out of that particular, we are going to break out of, or by breaking out, it means we are going to stop our iteration operation. So we are going to stop if it, so you'll see that we will iterate through all these items and we will get to viridian. We'll print out viridian, but we won't print out Corsa. So we went through the list for restaurants once, then Java, Nyamamama, Italian, viridian, then we broke out because this particular item turned out to be true, and the break statement is, we normally use it to stop the loop, and it stops there. Okay, so the next thing that we can do is to use another statement. Instead of stop and stop completely, we could decide to stop during this iteration. Maybe we have some other piece of code in here in the body of the for loop that we could want to execute. But if this turns out to be true, we might ignore the rest of the code, continue from, stop from where you have in this iteration, where you have gotten to this iteration, and continue to the next iteration. So how to be able to achieve that is using the continue statement, which will stop the current iteration and then continue to the next iteration. So for instance, here we have a list of mobile phones, or iPhone up to 10s. So if iPhone X, also if the current item, so the first one will be iPhone 4, and we'll go through that. iPhone 4, we go through this expression will not turn out to be true, or turn out to be false, so we won't run the body, which is the continue bit. We'll go to print line, and we will print out we'll print out the value of X, and we'll print out this string. So checked, then value of X. Remember how we printed out two strings while we were using print statements? That's what we're doing here. So checked phone, then we checked phone, iPhone 4, iPhone 5, iPhone 6. Once we get here, iPhone 6, we won't print out this statement. We will continue, because this has turned out to be true, one of them. Then we'll continue to iPhone 7, iPhone 8. Then it will turn out to be true. We'll continue. So we won't print out iPhone 6 and iPhone 8. We'll print out iPhone 4, 5, 7, 10, and XS, 10s. So the reason is because when we are iterating during the iterations for iPhone 6 and 8, we're actually not running this command. So we should be able to see that. iPhone 4, 5, we skip 6, we go 7, then X, then 10, and then XS, 10s. All right, work on the challenges, and then we will continue from there. All right, while loops. So while loops is more like a for loop. The only thing is that before you perform some sort of iteration, what happens is that you have some assessment during this process of starting your loop. So this particular, before even starting any sort of iteration, you first of all have to satisfy some sort of condition before you perform the loop. So a while loop executes a set of statements as long as a condition is true. So for instance, this is a new list. We have teachers. Then we define some sort of variable that we will call I. And that I will have this value 0. And then we determine the number of teachers, which is just we create another variable that will contain the length of the list. This is how we determine the length of a list. Usually we use a len function. And then we use a while keyword now to write our while loop. We say while I, which is this one, 0, is less than number of teachers, which is less than 10, then we are going to be looping. We're going to be looping if this particular statement turns out to be true. And during each and every iteration, we'll be incrementing the value of I by 1. So this particular iteration, this particular operation, when it comes to looping through, will only stop when, in our situation over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If 10, if 9 is 9, we will stop actually at 9 because no, we won't stop at 9. Let's see what happens. So number of teachers will be 9. So if I is less than 9, then we will print out the current teachers item. So to be John, then we go to Ruth, Naomi, Esther, Liz, Stephen, Lorna, Susan, then Ian. So if we try to print out, we can't be able to continue to the next iteration because when we get to Ian, we'll have gotten, let's go to John the first time. So I is equals to, it was 0. So 0 plus 1. So I is equals to 1. Then Ruth 2, Naomi 3, Esther 4, Liz 5, Stephen 6, Lorna 7, Susan 8, Ian 9. So when we get to 9, if 9 is not less than number of teachers, which is the number of the length of the list, then we won't be able to execute. We'll stop our loop. So a while loop just allows us to have some sort of operation before you perform this particular loop. It's more like using an if statement, then inside that if statement you use a for loop. Only that this is a whole lot more efficient altogether. This is another use case of a while loop. So you can also use a break statement. So inside the break statement, you remember how we used the for loop? Like for the break statement, when it came to the for loop, we decided to stop completely the iteration. So if, for instance, we had some expression inside our inside our while loop, and this expression turned out to be true, this is what we are seeing here. We can also break out, but you can also put this breakout somewhere where you want to break out. But generally, we want to break out of this loop if only this particular statement turns out to be true. So word, in our situation, word is Emma. So if Emma is equal to the current iteration, so which is here, we don't have any Emma, so which will actually continue to the very end. But if Emma appears as one of the items, then we will stop looping through a while loop. This is a long way, more like, but with a for loop, you can do it a bit easier. So if Emma turns out to be, which word turns out to be Emma, teachers I, then we will it will tell us find the element, which is Emma, at position I, and then we break out. So this is like more like a search application while loop. So teachers not defined. So we would need to define teachers. So let's run this. We had not run this. Then let's run this to be able to find that. So we did not have Emma. That's why it did not print out. But we can look for maybe Lorna. Let's change this to Lorna. And we should be able to find the Lorna is at element. Let's see, 1, 2, 3, 4, 5, 6, 7. Oh, 0, 1, 2, 3, 4, 5, 6. Remember, list usually starts from 0. So if I run this, I should find the element at position 0. Position 6, sorry. All right, just as we did here, we have a break statement. We can also use a continue. So remember, continue would stop the loop, the iteration where it is, and we would jump to the next one. We would not run anything that comes after. So that this is an application for loop. But here we also have this particular operator, which is equivalent to saying not equal to. If word is not equal to teachers, and the current item of that iteration, then we should be able to continue to the next element. So you can run that. If you haven't understood what's happening here, so we are iterating through the teachers list, which is here. This is the teachers list. And then in each iteration, we first of all print out checking element at the first one. So we print out the current element. Then we check whether if this particular variable, the value Emma, is it not equal to teachers, and that element, the current element. If it's not equal, we say I plus 1, we increment the value of y, which is this one, which will allow us to now move on to the next iteration, and then we continue. We stop in this iteration, and then we continue. But when we get to Emma, we will actually surpass this, and then we print out this statement, and generally say I is equals to number of teachers, which will be 9, which will just generally stop our loop. So that is actually what's happening there. All right, work on the challenges, then you come back and we'll work on the last bit of our course for today, which is functions. All right, so hope you're able to get a bit of that. So now let's continue to functions. So I mentioned to you earlier that we normally use functions to organize code and be able to have some reusable code. So in our situation over here, we might want to organize just generally code and be able to use that code repetitively. So just as an example, just to give you an idea, there are already what are called built-in functions, which are quite important, and they help us to have access to just some basic functions when it comes to Python. Like using the print function allows us to have access to code already written that allows us to output code. And there are other different kinds of functions that we might have come across, like len, which allows us to get it's like a function that allows us to print out the size of a particular sequence, say a list. So in our situation, we are going to work with, first of all, we're going to understand the different, some different inbuilt functions that we can work with. We have already worked with a couple: print, length, int, float. So here, assuming that we wanted to also work with another one, it's called the max function. It will find the largest or highest value in a list. So in our situation over here, our largest value would be 55. So we defined our list. We then used our function here to find the highest value in that list, and then we store it in X, then we print out X. Then we can also do the same here. We can also use the function with a list that contains just generally text data or string data, but we are going to use characters and all with how they usually appear alphabetically with regards to higher values. So SU would have a higher value than, say, something like Grace or GR. So first of all, we start off G has a lower value alphabetically than S and I, but SU has a higher value alphabetically than an I. So in such a situation, we would have Susan being outputted. So here we will have 55 and Susan. But now those are just inbuilt. That's an inbuilt function, but we can create our own function. So sometimes you might, of course, which is the holy grail of just working with functions, you can be able to organize your own code. So how we do that is, first of all, we usually work with a def keyword. We write def, then max of 2. This is the name of the function that we want. We can call our function whatever name that we want. Like the people who wrote Python decided to use the name print as a keyword, as the name of the print function. By the way, you cannot be able to use print. You can also not be able to use float, int, len, as variable names. They're usually called reserved keywords. But in our situation here, we can be able to write, we can be able to generally use our own names that we want, which of course later we cannot, which we can later onwards call. We can use them, we can call them in order to use these functions. As you can see, max of 2 with underscores, this is how we call that function, max of 2. But now we define def max of 2, the name of the function, and we have some parentheses here. Inside this parenthesis, we can define the input that we want that function to be taking. But for now, we want to create just a function that does not take any input. It just prints out some sort of output instead. So inside the function, we have a body. But by the way, when it comes to if statements, for loops, while loops, as well as functions, they usually have a body, which is you would have as the next line, which is just indented, or multiple couple of lines. Like for instance, the section over here is indented. There's space in between from the left hand side. You have to ensure that you cater this into account, or else you'll get some sort of error. So inside this function, we define these variables, and then we perform some sort of operation using our if statement. If number 10 is greater than second number, then this first number, then we return this first number. If this is true, if first number is greater than second number, which is not, we'll return the first number, or we just return the second number. You can write this efficiently. This is not just one of the ways, but this is just one of the ways. But if this statement doesn't turn out to be true, we just return the second number. And that is it, the end of our loop. So end of our function. So a function would normally take an input and return an output. Normally, most of the times it returns, but you can also have functions that don't return. In most cases, you would expect a function to have an input and return some output. In some cases, you might decide not even to return anything, just perform some operation without returning anything. And once you have written your function, so what's inside our body is this. We can be able to run this particular piece of code by just using the name of the function, marks of 2, then parentheses, and that's it. So we'll get 10, because if first number is greater than second number, which will run this line. Lastly, if we wanted to write maybe have inputs. So a function in our situation over here did not have an input. Inside this parenthesis, we did not define our inputs, but you can define an input. Like if you say that you have this value, the function will perform some operation, which is usually inside the body, and the output of that operation will be returned by the function. So we could do the same thing. So let's create another function. So a function called average of two numbers. This function will just take in two numbers. So we can just call those two numbers x and y. Then the two numbers that we want would be taken and performed operations on. So x and y are the pieces of data that would give this function. And inside the function, x and y would be added together, then divided by 2 and stored in this particular variable. And that variable will then print out the variable, that particular variable. And this is what we are going to be getting. So generally, we're going to be returning the average of two numbers in our situation over here. And if I run this, I should be able to, so this is what I also call average of two numbers. So 4 and 5. When I'm calling here, I did not specify any inputs. Here I'm specifying these two inputs. So 4 actually pertains to x and 5 pertains to y. So if I add another operator here, I won't be able to, you get an error. So ensure that whatever you're giving in terms of input or defining while you're calling a function actually is what is defined here. Now, when you're calling a function, these two inputs, these two values that go inside the parentheses are called arguments. And what is here is usually called a parameter. So we have two parameters, x and y, and arguments 4 and 5. That is something that you need to know. But arguments are normally different from parameters. So running that, you should get 4.5. And that's basically it. That's what you need to learn so far in terms of Python fundamentals. Now work on the challenges and then check your solution. Once you have checked your solution, the next thing that you need to do is to work on the project that we have provided. So this is the project that you will need to go through. There's a guiding notebook that will contain some starter code that will give you an idea of what you need to do in order to go through. Once you have gone through that, then check your solution. Just check your solution by going through our sample solution to see whether you have understood the content that we were meant to have already gone through. So the project might take you an hour or so. Just sure you're taking some breaks even in between the workshop, just to ensure that you are really understanding the content. Again, this is just an introductory session. It just covers some fundamental concepts. You would also cover some other further advanced fundamentals if you want. You could also do that. We'll be releasing some courses in the future. However, what you have learned so far would be important when you're also going to learn maybe something like data analysis. So one of the courses that I recommend people who are looking towards becoming data analysts or data scientists is to go through now data manipulation or data wrangling with Python workshop, which actually helps them to see how they can be able to put into place what we have learned so far in a context of data analytics or data science. And this course is also available on Afterwork, that data analysis or data wrangling with Python course, which you could always do. So I hope you're able to achieve these learning outcomes, being able to walk through these learning outcomes. Now, the print function, variables, work with variables, comments, arithmetic operators, data types, these dictionaries. We haven't gone through sets, but we did come across a set example somewhere. Work with conditional if statements, for loops, while loops, as well as functions. If you're watching this if you're doing this course on our Afterwork platform, we also usually have an opportunity for our students to be able to, or members to be able to have their projects reviewed. And you would get a certificate at the very end. So if that is something that you would want, once you have done the project, you could submit it on our Afterwork platform. That's afterwork.ai. Just submit it, and then we will just review it and then provide you with a certificate once you have once we have reviewed and are satisfied that you did a good job. But if you hadn't if you had made some comments or mistakes somewhere, we'll still send you feedback. You work on that feedback, and then we just send you again with a certificate. And that's it. That's it for this particular Python course. I hope you were able to learn a whole lot and you were able to feel confident. This is what you're going to be doing, working with code as a data scientist, a data analyst, or software engineer, or even whatever role that you're going to undertake maybe in the near future. And hopefully we'll be able to interact more than in other learning experiences and continue this learning journey of hoping to create impact later after these learning experiences. So that has been it. All the best, and see you in the next course if that is the decision that you want to take. All right, all the best and goodbye.